So let us start. Who knows what arXiv is? 1, 2, 3. Okay. So it is this website. Probably the website is not so immediately clear what it is. To give you an idea, it is a preprint server, the oldest preprint server we have. It was started in 1991, collecting scientific articles, publications. Articles mostly on mathematics, computer science, physics, and a few other computational biology, so we have a lot of categories. So if you think like 33 years ago, so since then we have a lot of articles that have been published and on our website. We are currently at about 2.4 million articles, all in, well, at the moment computer science is of course the biggest part. Physics is also very strong. And so it's actually accelerating. I mean, everyone is publish and perish, right? So a lot of articles are uploaded nowadays. So a few examples of what has been published on arXiv. I guess all of you have heard LLM, large language models, right? They were first published on arXiv. So the original article is on arXiv. The LIGO, the gravity wave, which got the Nobel Prize in physics some years ago, was published first on arXiv. And I'm a mathematician, so very famous, the Perelman gave a proof, one of the millennium conjectures, the Lagrange conjecture. He publishes also only, uploaded his work on arXiv and requested other scientists to look into this. So it is really the source of a lot of knowledge we have accumulated over the last years. It is true that a lot of articles we have at arXiv are first uploaded to arXiv and then published in more classical standard journals, you know, like whatever, computer science, mathematics. But we have also, I mentioned before the Perelman, we have also a lot of articles that are only published on arXiv. So this is an approach to open science. So we want the people can just upload and then other people can look in this and create an open discussion about these research results. So this is something we are striving for, and yeah, so arXiv is quite good at this. So open at arXiv. It's actually not only what I will discuss today. We have several things. So first of all, it's open science. If you are somehow in science, in academics, you probably heard the discussion about open science. You know, many are scientific articles. I'll come to this later. Then open source. So we use a lot of open source and we provide open source solutions. And it's open access under tick marks, because open access is often related to open science. In this respect, I considered accessibility. We want to make not our research, we want to make our service, the website, the research, everything accessible to everyone. That includes people that are visually impaired, have hypersensitivity. So there are a lot of things that we need to take into account. This is mostly the topic of today, but I will go through the other two very short. So open science, so there is no paywall. If you ever have tried to download the paper from the JSTOR and you are not an institutional member, you are asked for like $70 for a single PDF file of an article you might need for your research. So this is not in our case, it's completely open access to all articles. And above that, also the sources of all articles. So it's not only the finished PDF, but actually the text sources are available for not all, for about 90% of our articles. Thinking back from the 2.4 million, this is quite a lot. So that was a decision by the founders of arXiv, Paul Ginsberg and his co-workers. It was a conscious decision back then to request submitters to submit also the tech code. And that is very helpful, we will see later, because we can now do things with the tech code, like convert it to HTML, which with pure PDF would not be possible. So open source, so we use a lot of open source. It's also a generational divide. So we use TeX. It's a typesetting system, very popular, very common in mathematics, physics, a bit less in computer science, but still. So this is just, you have a text file and it's converted to a PDF more or less. And we use another an open source program, LaTeXML, which is developed by NIST. I will go into this a bit later. We also produce open source, not that much, I have to say, but still we have a version of Autotech that was our automatic system, or is still our automatic system to convert. Now, you don't want to dive in the code. It's on CBAN, it is 40 or 30 years old Perl code. It's not fun to read. It does what it does, but we are rewriting everything in Python now, and also Dockerizing. So we are working on to provide an open source text to PDF container that can used as providing an API. That is what we will use, or already partially using on the arXiv websites already. So that is in process, and we will do this in future. So open access. Now, open access, you probably have heard about accessibility, right? A lot of activity we will have here after lunch break. We have a talk about accessibility and finding errors in accessibilities. Now, accessibility, what does it mean? Not all people are equal, and not all people have the same ability. So for very simple, blind people cannot easily read the website, right? They need special tools. Now, there has been a lot of work in this direction, W3C standards, guidelines, how to make websites, so HTML source code accessible. The reason is because there are screen readers, there are a lot of tools for people that can help access content without actually seeing it. The problem with the arXiv website, so our website by itself is accessible. So that was the easy part actually. But is this real accessibility? I mean, our biggest problem is like what we really provide are PDF files of research. Now, the big problem is that PDF format is not really accessible. So, I mean, I don't go into details. There's a lot of new standards, also PDF 2.0 and general accessibility, but we are far from a state where PDF can be used for handicapped people. So just to give you a simple example, so this is a typical, okay, that doesn't work, the pointer. So this is a typical research article. I just picked one from the last few days in mathematics, something I understand. It's about P and P. So it's a typical page. You see so I mean, if you have ever read a research article, you probably have seen something like this. So it's a digitization of a page, where actually it was meant to be printed and then, well, read like a book. But in reality, we all are aware that the mismatch between, you see already here, the mismatch between the page geometry and how our screens are orientated is a huge problem. You normally don't turn your laptop, right, to read your screen. So what happens? You have to scroll. If you zoom in, you have to scroll horizontally. So this is really a problem. There is a few work going on. So if you heard, PDF has developed this, something called the liquid mode to allow for reflow of PDFs. The problem is restricted to mobiles and it's commercial, so nobody can use this. So, well, it's not really a solution we can use. So improvements in reflow, so that this is not always like this. It's more like HTML, you know, like HTML, if you make your browser more narrow or wider, then, well, the text changes, right? This is called reflowing. That doesn't work with PDF. You have to scroll around. So that would help a lot. Then other PDF limitations. Now, I don't expect you to understand what is written there. So this is the actual content of a PDF file. It's actually a paper that I published myself. You see, the structure is completely lost. So what is here written, this part, is the title and the authors. So separating intermediate logics of whatever, yeah, so something I wrote. Yeah, and there is no structure in here. The structure in PDF is completely lost. So it's just put the letter here, put the letter here, put the letter here, put the letter here. That doesn't help people who want to have something that is accessible, because you want to know section, paragraph, I want to go to the next paragraph, I want to look into formulas. So section, heading, caption, these are all just typographic markup, nothing else. So again, Adobe is of course aware of this. They have developed something that is called tagged PDF that tries to eliminate these problems by adding information into the PDF. We have a problem, most documents are not tagged, and we don't have viewers that support them. And also from the LaTeX side, there is only very preliminary support to generate tagged PDF. So, well, that's not really an approach we can offer for accessibility. And so we have a lot of researchers that are handicapped in the sense they cannot see or have high sensibility. They need different changes. They tell you one thing: please use HTML. There's a very simple thing. Why? Because HTML is by design responsible. You have responsive design, it reflows automatically. Nowadays, most browsers have something like dark mode. People who are very sensitive to white colors would like to have a dark mode because otherwise they cannot read it. Not really related to this, built-in translations. Now, most browsers provide built-in translations for HTML. This is also a kind of accessibility. If you are not fluent in English, you might enjoy getting at least a bit of support of automatic translation. There are a lot of add-ons for dyslexia. Dyslexia is when the order of characters, of letters are changed, so you read them incorrectly, and visually impaired everything. Another thing that HTML, if you are not a complete maniac, then HTML preserves the structure. Of course, you can write HTML like PDF before, like always make a big font, make a small font, but normally you do it with markup. You say, this is the header, this is a paragraph, this is a table. So every normal HTML document has proper markup, which is then accessible. There's a rich marketplace of assistive technologies. There are a lot of plugins for handicapped people they can use. They are used to them. They are very fast doing them. They are very efficient in reading stuff. Not to speak of search engines, work much better with HTML than PDF. Extraction of text from PDF. Again, if you look back at this, so extraction of text from here is a bit more complicated because sometimes, well, words are split up. You need to halfway interpret this. And text harvesting is all much easier. Just to give you an idea, the archive corpus is part of practically every LLM that is trained because it's open, so yeah, everyone has access. So, but there is one problem, right? We mentioned it before. All the scientific articles are in PDF, and yeah, converting PDF to HTML is really hard. So as I said before, the structure is lost. So there was a project by Allen Institute of AI. They tried with an AI model to generate from PDF the HTML. And so by AI model detecting, recreating the original structure. But that didn't work out quite well. So what we then decided is because we have 90% of the articles have the text source, right? To start at the text source. So now I don't get crazy. I will not give you an introduction to TeX. Just to give you an idea, TeX or LaTeX in is a text file. You create a text file here on the left side, and it is compiled to a PDF. The PDF doesn't have a structure, right? It's just typographic stuff. But the document itself, and this is really the whole document produces this one, you have a section, you can have title, section, subsection, and this is all marked up. It's not HTML, but it's very similar. It's a different kind of markup. So this markup has the advantage that if we can reuse this to convert to HTML, that would be very nice. So another thing why it's so popular in science, because it is really good in mathematics. And if you ever have tried to enter formulas into a WinWord document and then looked at the output, then you are, this is very disingenuous. So Knut generated a very standard language to convey mathematical expressions. This is actually used even in Microsoft products nowadays. So this is the standard language between scientists nowadays if they want to commute a formula. Many people use this without using tech by itself, just to communicate. And for example, this here would create the formula on the side, right? Okay, that was all I showed you of tech code. No worry, no more tech code here. So a bit of history tech. So it was invented by Donald Knuth, very famous for the art of computer programming. You know the story, who was it, who said that the Apple guy said, if you have read through all of the books of Knuth, of the art of computer programming, you get a permanent position out of without having an interview. So Knuth was just frustrated with the printing quality. Back then, in the 60s, everything was printed. Well, I don't get into the linotype optical printing. So he was very fed up with the quality of the print. So he invented his own typesetting system, his own font design system, his own fonts, just to set his own books. Yeah, well, this language. So it is very similar to other languages back in the times. Scribe is still around. Most people haven't heard of it. Runoff also. And the language he created is actually a Turing-complete language. So now, what does it mean? It's, well, practically it's a full-fledged programming language. Turing-complete means you can compute whatever you want with tech. It might take a bit long, but it's, yeah. This is a blessing in the sense that users can create very complicated stuff, very detailed graphics, very nice layout, but it's also a curse because reinterpretation is very hard. Lots of people do a lot of crazy stuff. So converting LaTeX to HTML was our aim because it's the only thing we can do. From PDF that didn't work properly, so we started from LaTeX. We have, as I said before, nowadays 90% of the papers that are nowadays submitted are written in LaTeX. We have very few exceptions for different. We have very few exceptions for people not uploading the source code, so we have the LaTeX code available. The problems, how to write the LaTeX to HTML compiler, yeah, everyone could say, okay, this is a nice holiday project. Let's write the LaTeX to HTML compiler, right? If you look at the sources here, it looks not that complicated to parse and write, right? I mean, that is H1, H2, blah, 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 so not so hard, right? Well, unfortunately, it is very hard because the tech compiler itself ignores at the end, at the output side, all the structure. It's all just typographic setting. The simple things like, as I mentioned before, a section or something, these are easy to do, but there are hundreds, thousands of packages that add additional functionality to LaTeX, and they all have to be hand added for a special case for the translation. So this is a huge undertaking. So we looked at the current solutions there is LaTeXML, this is developed by Bruce and Dejan. There is Tech4HD that Ethan developed it for long, and now it's maintained by Michael. And then there's this text PDF I mentioned before, developed by the LaTeX core team. So the first two are more or less equal in quality, in success rates. So we compared them on a huge corpus of arXiv. We settled for LaTeXML. Why? Also because there was a project before, it's called arXiv, and you have to be careful here, there's a 5 here, yeah? It's not an X. That was this website Michael and Dejan and Michael set up already long years ago to provide HTML access to to archive papers. That was set up already. Of course, there were about 20% failures. Of course, there are visual glitches. But and it's costly. Yeah? Just to give you, so reconversion of articles, one article is $0.0015. Well, if you could multiply this by 2.4 million, you have a unfriendly amount of money you would for every iteration we have to do. So it's incomplete, I have to say. As I say, 20% are failing. A long list of packages we have not supported for the LaTeX infrastructure. One of the most famous is a famous graphing diagram package, TIX. There are edge cases, there are people who are authors who write really strange things. But, and that is the big but, it is something where handicapped researchers can work with. So the feedback was incredible. Everyone was like, big thanks, because they finally can read HTML papers. Sometimes there are errors, but before there was nothing. Now they have at least something, right? So for screen readers, I mean, they can live with glitches because they get more or less, like if it's like 80, 90% of the article, that is great, right? So that was a huge improvement we rolled out. Actually, it is rolled out. We rolled it out like 1.5 months ago. We brought this archive with 5 in-house. We are working with them very together. The submission process already, we want to motivate authors that on submission they check the HTML and maybe help to make it better with respect to accessibility. It's not blocked by now, but this will probably not come in the future. Okay, a bit for the user interface since we are running out of time. So if you ever have looked into, that is the paper I showed you before. So before there was always only this few PDF and the text source and maybe other formats, and now we have the HTML here. So that is new. You can click on that. What you get here is then a page. It stays better. We are not, well, it's not perfect. It shows the table of contents, so we extract, you can navigate, also very important for screen readers. We also show warnings about things that didn't work in the conversion, because, well, we are gathering feedback. So we support formulas and everything, dark mode, and we always have a huge report issue, because we want everyone to report issues with the conversion so that we improve the stuff. And that was an incredible feedback. We have thousands of reports already. So people are really happy about this feature and use it. But you see, I mean, this is not images, right? These are actual formulas in MassML. So blind people can read this with screen readers. That's a huge improvement. Before it was absolutely impossible. So what do we want to do in the future? So work with LaTeXML team to improve conversion rates, improve visual glitches, cost-effective way to recompile. At the moment, we only convert new submissions, but not the old, because 2.4 million is a lot and costs a lot of money. We also look into, in the future, also to provide accessible PDF. This is when the LaTeX core teamwork is ready for the tagged PDFs. A big topic is charts and graphs, very difficult, right? I mean, it's often a lot of data is hidden behind a graph, charts. So, and here getting information out of it is very hard. Yeah, providing the data behind graphs, because that is what helps. And then auto-captioning, like we want authors to actually add alternated text. But if they don't provide, we are thinking about using AI models to auto-generate descriptions. So as a summary, accessibility is very important. There are a lot of researchers who wait for this for a long time. The feedback was incredibly positive. So not only from handicapped people, so from a lot of people who want to read papers that reflow automatically. So there's a lot of extremely positive feedback. We are still far from the last mile. Even from the last mile, we are far away. There are a lot of packages we have to work with, a lot of support that has to improve. But, and that is something which is really important, I mean, it provides a service to the community that is now here, that has been not available for many, many years. Just for those who are interested, we are also running an arXiv accessibility forum later this year. The website is open since very recently. Well, it will be soon be published in a blog post also. Yeah, last but not least, a few of acknowledgements. First of all, we all want to thank the researchers, the blind researchers, the handicapped researchers with whom we have worked. They gave incredible feedback. So we have a lot of interviews, permanent checks with them. Does this work for you? Does this helpful? They have provided incredible input for improving the situation. Then the usual statement that this is supported by the NSF and everything is my own order meaning. And last but not least, I have joined arXiv recently. I don't want to say this is work I have done. This is the work of the arXiv team. It's their improvements. I'm recently joined and I'm working forward. There's also my email if you want to check me. So it's norbert@arxiv.org, very easy to remember. And that's all, I think. Thanks a lot for the attention.